Hello, second grade scientists, and welcome back to Science with Mrs. Miller. Today in Lesson 7, we will be exploring yet another property of matter. This property is called density. Can you say density? Ready? 3, 2, 1. Density. That's right. We're going to be exploring density today. I wonder if you know what that word means. What is density? Have you ever heard that word before? Thumbs up if you've heard it and you feel like you might know what it means. Thumbs sideways if you're like, sounds familiar, but I'm not quite sure. And thumbs down if you've never heard that word density before. That might be a brand new vocabulary word for us. That is a very grown-up science word, and we're going to learn about what it means. So let's read this book to learn all about this very sophisticated word, density. Density. First Science, written by Kay Manolis. Let's take a look at the table of contents over here. What is density? Density in water, density in air. And then there's a glossary to learn more and an index. What is density? Only 2 fish live in this tank. Many more fish live in this tank. This tank has a much higher density of fish than the first tank. Density is a measure of the amount of objects in a certain space. Now, before I read this page, I just want to point something out to you. I had said that density is a very grown-up science word. It's also a word that's used in social studies. We'll be using this word will be coming up again later on in our year in social studies, but you'll get a little preview here. Here we go. Density can tell you how crowded an area is. Many people live close together in this neighborhood. It has a high population density. Fewer people live in this area. This area has a much lower population density. So if you take a look at these two separate areas, this picture shows us a much denser population. Do you see how many houses there are? And they're all packed together. And then take a look at this picture. This shows us a population that's much less dense. Not many houses, not many people living there, and they're spread apart. Density can also help describe a single object. It tells how much material an object contains compared with the amount of space the object takes up. Everything in the world is made of extremely tiny parts called molecules. Everyone say molecules. 3, 2, 1. Molecules. That's right. These are clumps of even smaller pieces called atoms. Millions of molecules could fit on the tip of a pencil. Just imagine that. Take a look at the tip of this pencil. It has millions of molecules in it. Molecules must be really, really, really tiny. Solid things such as people and toys are made of molecules. Liquids such as water are also made of them. Even gases such as air are made of molecules. Molecules are arranged differently in solids, liquids, and gases. Molecules inside solid materials are crowded together. So think of that picture that we saw before. Remember how we saw it looked like a very crowded neighborhood, right? Where all the houses were together. So in solids, the molecules are packed together just like that neighborhood with lots and lots of houses. Materials that have many molecules in a small area have high densities. Molecules in liquids usually have more space around them. Compared to solids, there are fewer molecules in the same area. Gas molecules have even more space around them. There are even fewer molecules in the same area. Gases have low densities. And here's a fun fact. Submarines have tanks that fill with either air or water. When the tanks fill with air, the whole submarine has a lower density than water, so it floats. When the tanks fill with water, the submarine's density is higher than water, so it sinks. Imagine two objects that are about the same size but have different densities. The object with more density will weigh more. For example, this brick is made of clay, which is very dense. This sponge is much less dense than clay. The two objects take up about the same amount of space, but the brick weighs a lot more. So wait, just refresh my memory. Which object would be denser? A brick or a sponge? Which one is denser? Meaning that the molecules are all smushed together and there are a lot more of them. It's denser, it's heavier. Call it out in 3, 2, 1. The brick. Yes, the brick is denser than the sponge. Density in water. A marble sinks in water. A beach ball floats. An object's density determines whether it will sink or float. An object will sink if its density is higher than water's density. An object will float if its density is lower than water's density. And here's a fun fact. Many ships are made of steel. Ordinarily, steel sinks in water. The shape of the ship holds a lot of air. This lets heavy steel float. Water behaves differently than other materials. Most objects become more dense when they change from a liquid to a solid. When water freezes into ice, its molecules move further apart. This means ice is less dense than water. That is why ice floats on water. Even huge icebergs float in water. Fun fact, the density of ice is only slightly lower than that of water. For that reason, ice floats low on the surface of water. This means that most of an iceberg floats below the surface. Density in air. Objects rise in air if their density is lower than the density of air. For example, these balloons are filled with a gas called helium. Helium's density is lower than air's density. These balloons were filled by someone's breath. Human breath has density that is higher than air's density. These balloons sink to the floor. The molecules in hot air spread out more than those in cooler air. Hot air has a lower density than cooler air, so hot air rises. A hot air balloon works because of density. A burner heats air and lowers its density. The hot air rises and lifts the balloon. When the air cools or some hot air is let out, the balloon comes down again. Okay, so now I want you to think, what does that word density mean to you? What did we just learn about that word? Can you use the word density in a sentence? Can you explain to a friend what the word density means? Think. In just a moment, I'm going to ask you to turn and talk to somebody next to you. All right, I'm going to give you 15 seconds now to turn and talk to somebody next to you about what that word density means. If you're at home, talk to someone in your house or your imaginary science partner. If you're in school, talk to someone who's sitting near you. Ready, set, turn and talk. time is up. Stop, look, and listen. So I'm wondering if you said something similar to what I was thinking. I learned from this book that density tells us how many things are packed together and how tightly. So when we're talking about one object and we're thinking about the molecules inside of the object, when there are a lot of molecules and they're all really packed together tightly, that object has high density, like a brick, for instance, right? I also know that the denser an object is, the heavier it is, and the less dense it is, the lighter it is. All right, now Science Max is going to explain a little bit more about this idea of density. So let's listen and watch closely, because we'll get an introduction to an activity that's very similar to a science activity that you and I will be doing together shortly.
Did you know it's easier to float in salt water, like in the ocean, than it is in fresh water, like a lake or a pool? That's because not all liquids are created equal. They have different densities. This is fresh water, or it doesn't have anything in it. And this is sugar. If I was to put 1 scoop of sugar in this water and stir it around until it dissolves, now this liquid is more dense than before I put the sugar in. Here's an experiment you can do at home using liquid density. This glass just has regular water with yellow food coloring in it. This glass, green food coloring and half a cup of sugar in it. This one has a full cup of sugar in it, and this one has 2 cups of sugar in it. Now, when you do this at home, you'll definitely want an adult to help you, because you have to heat the water if you want to dissolve that much sugar in 1 glass of water. I'm going to put them all in 1 container. You can do this at home, and when you do, I suggest you use a very small container, because you have to be very careful when you put the layers in. You can use a turkey baster or a straw. When you put your finger on top, the air pressure will hold the liquid in, and you can just drop it in. But these kind of take some time, so I'm going to use the syringe of science. I'm going to use the most dense liquid first, because that's the one that's going to want to be on the bottom. I carefully put it on the bottom of the container. The next layer, be very careful, and you'll see that the red and the blue aren't mixing because they have different densities. The blue is heavier than the red. We'll add the green, and you can see even when it drips into the red, it comes back up to the top, because the green liquid isn't as dense as the red liquid, and the denser liquids push the lighter liquid up. And now we're going to add the yellow, which of course has no sugar in it at all. And there you go. All the layers stay separate. If you put it on a light, you can really see it. Liquid densities. Now, let's max it out. Ta-da! The longest...
All right, we'll come back to Science Max later to see how he maxes out this experiment. Now it's time for us to do a science activity of our own. So you will need a density of liquids activity, and it looks like this. So if you're learning from home, you'll find it in your Google Classroom, and as usual, if you're learning from school, your teacher will give it to you. If you don't have that sheet yet, please pause the video here and come back when you do have it. You will need this sheet for our activity. Just like Science Max did with his sugar water, we are going to build layers with different liquids. So instead of using sugar water, I thought it could be fun to use different types of liquids. So let me show you what we have here. Here we have a cup of water that I have added red food coloring to. Then here we have some oil. Okay, it's actually vegetable oil. You can see it's yellow. And then here we have some blue dish liquid. So let's start by making a prediction. If you look at your sheet, it says second grade science, unit 1, lesson 7. Density of liquids. In what order will the liquids settle in the cup? I should say glass. I'll fix this on yours. Couple more typos. Okay, so which liquid do you think will be on top? Which do you think will be in the middle? And which do you think will be on the bottom? Before you answer that, which will the most dense or the least dense liquid sink to the bottom? What do you think? Call it out in 3, 2, 1. Most dense. That's right. The most dense liquid will sink to the bottom. So think about which liquid you think is most dense and which liquid you think is least dense, and then which liquid you think is sort of in the middle. Okay? Pause the video here and make your prediction. And remember, our prediction doesn't have to be right. We are going to do what scientists do and seek out to prove our predictions, right? Because scientists say, I like to prove it, prove it. I like to prove it, prove it. I like to prove it, prove it. I like to prove it. Go ahead and write which liquid you think will settle at the top, middle, and bottom. All right, I made my prediction. I wrote that my prediction is that the water will be up top. I think that might be the least dense. Then the oil, and then the dish soap would be most dense. If you haven't finished making your prediction, you can use my words here to help you. But think about what prediction you'd like to make. Your prediction doesn't need to be the same as mine. We don't know if my prediction is right. We have to test my prediction, and we have to test your prediction. So go ahead and do that. If you haven't finished writing, pause the video again and finish writing those words, water, oil, or dish soap, in the order that you think that they will go. All right, and now the moment we've all been waiting for. It's time for us to test our prediction. Let's see which liquid is most dense and which liquid is least dense. I'm going to start by pouring in the dish soap. Okay, pour a whole bunch in so you can see. All right. The first layer I poured in. Next, I am going to pour in the oil, the vegetable oil. Let's see what happens. I'm going to pour it in slowly. Let's see which one settles to the top and which one settles to the bottom. Oh. Look at that. We could see a clear line between the oil and the dish soap. Do you see that? So, which liquid is denser? The dish soap or the oil? That's right, the dish soap is denser. Now, I wonder what will happen when we pour the water in. I wonder if it will sink or if it will float on top. Pour a whole bunch in. Okay, and then let me give it some time to settle. Do you see what's happening? Wow, look at that. Do you see how it's separating? The water settled to the middle, and the oil is floating on the top. That's not what I expected to see. Is that what you expected to see? Did that match your prediction? All right, now we can write down the actual observation. What actually happened? So on the top was the, call it out. Let's look. Call it out in 3, 2, 1. Oil, that's right. On top was the oil. In the middle was the red. Call it out in 3, 2, 1. Water. Water settled to the middle. And on the bottom was the, call it out in 3, 2, 1. That's right, the dish soap. Okay. Now, after you have finished filling in your chart here, we have some questions to answer. So I want you to go on and answer them on your own. Which liquid sank to the bottom? Why? Why did it sink to the bottom? Make sure that you use that word dense, denser, or density to explain why the dish soap sank to the bottom. Which liquid floated on top? Why? Then, this is really a deep thinking question. Think about this. When there is an oil spill in the ocean, where do you think the oil goes? Think about that. Would the oil float on the top or sink to the bottom? Based on what you know about oil's density and water's density. Think about which is denser, oil or water. And last but not least, how might an oil spill affect animals such as birds that eat fish? Interesting. Think about that. Okay, I want you to pause the video here, complete your activity sheet, and then come back so that we can watch Science Max max out this liquid density experiment. Welcome back, everyone. Did you finish your density of liquids activity sheet? If you didn't, make sure that you finish that now. Pause again and finish that before you watch this video. And if you did, then we're going to watch now how Science Max maxes out this science experiment.
Densities. Now, let's max it out. Ta-da! The longest length of liquid layers. 12 liquids, all organized by density. Starting from the bottom, we have honey, corn syrup, chocolate syrup, maple syrup, dish soap, whole milk, water, dyed blue, vegetable oil, extra virgin olive oil, rubbing alcohol, baby oil, and lamp oil. Liquid density. I really want to mix it up, but it took me a long time to make this, so I'm not going to. Our first two...
Pretty cool how Max used so many different layers in his experiment. Now, you can do this at home too. Make sure that you have an adult with you to help you and only use liquids that are safe to use. But try using different liquids to see if you can build layers of liquid density. Have fun, and then if you're looking for even something more to do, you could try this as an enrichment activity. What do you think? On your mark, get set, pour. Pour 1 tablespoon of water, olive oil, and honey into 3 separate spoons. With the help of 2 friends, pour each liquid from the spoons into a bowl at the same time. Which liquid reaches the bottom of the bowl first? Which one wins the race? Have fun, everyone. It was so much fun learning with you today. I'll see you next time. Bye-bye, scientists.